the rings, breaking it into parts. Now, that's what we were trying to build. We're trying to build the question, the thought process behind this question. So let's come back to the question. And here, you might be wondering, what powers are we going to use? Powers of 2, powers of 3, powers of 4, powers of 5. The question is slightly different. Let's understand. Let's ask yourself with mathematical induction, if there is only one ring, how many times you need a cut? You don't need a cut, right? If there are two rings, how many cuts do you need? You will cut this ring here, let's say, and this ring is available for you, and this other ring is available for you. You will get a cut ring. With one cut, you can give any number of ring, either 1 or 2, right? Are we okay? 1 or both of them. If there are 3 rings, what can we do? We can cut either here or in the center, and we'll have one separate ring which is cut and 2 joint rings. You can give, still with one cut, you're able to give 1 ring, you're able to give 2, or you're able to give all 3. What if there are 4 rings? Now what? Now this is where the question becomes a little cheesy. What if I cut somewhere right here? So I have 2 rings, I have 1 cut ring, and I have 1 ring which is intact. Right? We have made only 1 cut, guys. We have made 1 cut, right? So we can give 1, we can give 1 plus 1, 2, we can give 2 plus 1, 3, we can give 2 plus 1 plus 1, that is 4. In fact, it is still 1. The question is not the powers of 2 and powers of 3. The question is, what do you need next, right, to make this happen? If there are 5 rings, same way I'll make a cut here. So we have 2 separate, we have 2 separate, and 1 separate. Now this makes it still possible to give all 5, any number from 1 to 5, 1, 2 plus 1, we can give 3, we can give 2, we can give 2 plus 2, 4, we can give 5. Every number is possible. In fact, even if you check for 6, you cut it somewhere here. So we have 3 rings, right? 3 rings as a loop, as a linear chain, another 2 rings as a linear chain, and third one is separate, right? We can produce 1, we can produce 2, we can produce 3. This is 1, this is 2, that is 3. We can produce 3 plus 1, that is 4. We can produce 3 plus 2, that is 5. And finally, we can produce 3 plus 2 plus 1, that is 6. So all numbers are possible. What if I have 7? And I think with 7, we'll get to the solution right away, right? If you have 7, right, and that's the intriguing part here. If you have 7, let's say we cut it here. So we have 1, 2, 3, right? We have 1, 2, 3, 4. We have 1, 2, right? And we have the separate one, right? This is where the cut was, right? This is where this cut was that we are trying to identify with, right? So we had 7 rings, and we cut it somewhere here. We cut it somewhere here, and this is the cut piece, right? So we can give 1, we can give 2, we can give 2 plus 1, that is 3. We can give 4, 4 plus 1, 5, 4 plus 2, 6, and 4 plus 2 plus 1, 7. So all numbers are possible. But let's do one thing. Let's try it for 8. With 8, is it possible? Let's make a cut somewhere in between. So probably you can make 1, 2, 3, 4, 5, 6, 7, 8 ring. Where do you want to place the cut? Obviously not at the first ring, somewhere in middle. Let's say we made the cut here, or we made the cut here. That means we have 3 rings here. We have 1 separate ring, and we have 4 rings here, right? Or we made the cut at the third ring. We have 2 separate rings here, 1 cut ring, and we have 5 rings as a loop. Here you'll notice we can make 1. We cannot make 2. We can definitely make 3, 4, 5, 6, 7. We cannot make 6 again. Right? That's not allowed. But we can make 3. We can make 4. We can make 5. We can make 7, and we can make 8. Here there's another problem. We can make 1. We can make 2. We can make 3. We cannot make 4. We can, however, make 5. We can make 6. We can make 7. So not all is allowed. That means the moment we have 8 rings in context, you require minimum 2 cuts. So the question, anyway, we cannot continue doing this forever, right? We have 23 rings. We have 23 rings. Let me just number them quickly. Let me just number them right quickly. 17, 18, 19, 20, 21, 22, 23. So that is 23rd ring. So we are sure the number of cuts is greater than 1. It could be 2, it could be 3, it could be 4, it could be any number, but we know it's a number greater than 1. So if you're sure that there will be 2 rings, because it's a number greater than 1, that means we need to have at least 2 rings out, right, from somewhere. That means we will get 1, we'll get 1, 1 plus 1, 2. So if we make a cut here, what will happen? If we make a cut here, if we make a cut at after the third ring, that means at the fourth ring, if we make a cut at the fourth ring, I'm taking of this ring, okay? If we make a cut at the end of the fourth ring, so we have what? We have 1, 2, 3 as a loop, plus we have 1, plus we have 1. That means we can put any number from 1 to 5. What's the problem? The problem is we don't have 6. That means from here, if we start 1, 2, 3, 4, 5, 6, if we move here and make a cut after 6, right? After 6 rings, if we make a cut, that means at the 11th ring, if we make a cut. So this is the cut at the 4th ring. We need another cut at the 11th ring, right? If we make a cut at the 11th ring, what's going to happen? If we make a cut at the 11th ring, let's do that. Let's make a cut at the 11th ring, right? So what do we have? We produce a loop of 6 rings, right? You see what's happening. The beauty here, you wanted to have 6, so you made a 6, like the previous question, right? We wanted to give somebody 2 rupees, or we wanted a weight like 5 kg. So what did you do? You did 9 minus 4, and this is more intriguing, but it's not just addition and subtraction, this is beyond it, right? So at the 4th ring you made a cut, at the 11th ring you made a cut. So now you have 3 plus 1 plus 1, that's 5. We found every number. We have 6, and 6, 1 to 5, we have every number we could do, right? So we have 6 plus 5 till 11, we have every number. What is the next thing we don't have? We don't have 12. The rest of the 12 rings can come here. It's damn simple. Rest of the 12 rings here. So we have a set of 12 rings here. We have a single ring here. We have 6 rings here. We have 1 ring here, and we have 3 rings here. What is the number of cuts we did? We did only 2 cuts. 1 and 1. And you see every number is possible. Now someone might ask how to make 19, right? Simple. 12 plus 6 plus 1. How to make 21? Again simple. 12 plus 6 plus 3, that's 21. How to make 15, right? That's okay. 12 plus 3. How to make 17, right? That's 12 plus 3 plus 1 plus 1, right? That is 17. 12 plus 3 plus 1 plus 1. In fact, every number is now allowed, right? So the thought process is, guys, is this a cat level question? Bet you it is higher than cat level question. But the question is, are we thinking? Are we thinking at that level? If you can start thinking at this level, forget LRDI, right? That is a small task. This is all bringing you to think cognitively. This is all making you to think laterally. This is all making you, to think analytically. And CAT is just an exam. I know it's tough. I know you want to crack it, right? But trust me, here, what we are trying to build is a person who can think in such a way that you become the best product developers in the world. You become the best strategic consultant in the world. You become something which a company looks to. You can be a person who can probably work to revolutionize the way you're already thinking, right? That's essentially what we want you to achieve in life. That means think logically and make yourself to help the entire setup of wherever you're working, right? That's exactly how you should start thinking from here. And I'm sure you guys are with me. So, we'll move to another set of questions, right? That took a lot of time, I know, but I hope this is drilled down, because I'm not going to take this logic too many times again, right? Wanted to build a process. You'd have noticed we have done 5 preliminary things before starting of this question, right? So that's some kind of a question for all of you, right?